In this video, we are going to take our knowledge of sine and cosine and graph them. First of all, we're going to just take a look at sine first, and we need to remember all of our sine values all the way to 360 degrees, or 2 pi. And when we recall the values of sine, when we have to go to a graph and plot points, knowing where sine values like root 3 over 2 and root 2 over 2, those are not values that we tend to know by heart, so we're not going to use them when we graph it. What we are going to use are our quadrant values. So we're going to start at 0. And our next quadrant value would be 90 degrees, but we're going to go by pi over 2. Everything that we talk about from sine and cosine in this entire tutorial video is going to be in radians. So this is our 90 degree measure. We need the next one, which is 180, which is pi. Our next one at 270, which is 3 pi over 2. And then our final, our 360, which is 2 pi. This gives us 1, 2, 3, 4, 5 key points. These are the only points that we are going to move. Everything else that we graph with this, we can alter and change based on the different things that are going to happen inside the sine function. So, just recalling, the sine of 0 is 0, and then we go to 1, and then 0, and then -1, and then 0. So these are the points that I want you to plot with me. We are just going to take a look at the first quadrant, or the first rotation anyways. So here's our 0. We're going to put 2 pi all the way out here at the end. Pi would be right smack dab in the middle. This would be our pi over 2. And this would be our 3 pi over 2. Also notice that because on our unit circle, none of the radii will ever be greater than 1. So we're going to have a maximum of 1 and a minimum of -1. So we're just going to start plotting this. We've got 0, 0, which I already have here at the origin. Pi over 2, +1, that's up here. Pi 0, 3 pi over 2, -1, and 2 pi 0. This is not a zigzag, this is a curve. So when we connect these, we go up and down and back up. So this is what our parent function for sine will always look like. And based on the different kinds of transformations that we have, it can be flatter. It can be squishier. In other words, the period is reduced, so I'll have that curve happen in a smaller amount of time. It can move to the left, so instead of starting here, maybe I start over here, and then the same pattern would happen. Okay? It can also be moved up and down, so instead of starting here, maybe I start here, and then everything would just be above it. So we're going to take a look at all of those different changes on our sine curve, and then we're going to move it to the cosine curve. Okay, so first of all, we're going to start by graphing our parent function so that we can change it very simply. The function that we're actually going to be focused on graphing is this one here in red, f of x equals 1/2 sine x. So this coefficient, if you ever have a coefficient of sine, a number in front of it, that is actually affecting amplitude. And amplitude is how far your function is stretched up and down. So first, let's graph our parent function, which is 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, 2 pi 0. And we're going to do this, and I'm going to use a dashed line so I don't get confused with what I'm actually supposed to be looking at, which is the red function. All right, there we go. Now, the amplitude is actually written in our parent function. You just can't see it. The coefficient that's sitting right here in front of sine is 1. And notice that that is the highest and lowest point that you have. Another way to look at it is it's always going to be the distance from a peak to what we call the midline. And a midline can move, it can change if you're moving it up and down, but the midline cuts your function in half horizontally, okay? So the midline in this particular case is going to run right here. Okay, so the distance from that midline to a peak is 1 unit. If you look at this other part over here, if this is my base and that's my peak, we don't say that it has a length of -1, even though it's below the x-axis. Amplitude is always going to be a positive value because it's representing a distance, and distance, as we know, it cannot be negative. So the question that we have to ask is, how do I use our 5 key points, the ones that are plotted, to help me fix the amplitude on this red function? And really, the amplitude only affects the peaks. Okay, that's the only thing that needs to change. So instead of this peak being up here at 1, it's actually going to be at 1/2 instead, which would be about here. And this peak, instead of being at -1, is going to be at -1/2 instead. Our other 3 points that are on the midline don't move. The amplitude does not change those other points that are on the horizontal axis. So all we need to do now is connect our points, and we have our transformed function with amplitude. The next graph that we're going to look at is going to have a different transformation. This time we have this +1 out at the end. Notice that there are no sets of parentheses here. It needs to be a number that is added or subtracted completely on its own, outside of parentheses, outside of the function. If you look back at the parent function, we also have that vertical shift being represented. It's just a 0. So there's still a vertical shift marker here. It just tells you to not move it. In this case, this tells you move everything up 1 unit. And the reason why it's up is because it's positive. If it were -1 instead, you would move it down. Now, this vertical shift, which I abbreviate as VS, moves the entire function up and down. In other words, we're going to move every single one of our 5 key points up 1 unit. So the first one, all the way to the left, our origin point, we're going to move it up 1 unit right there. This point, our first positive peak, also needs to move up 1 unit, so I need to include a 2 on my y-axis and place that here instead. My pi coordinate here needs to move up 1 unit, so now I'm at 1 there. At 3 pi over 2, if this bottom peak, if this minimum moves up a unit, I'm now at the horizontal axis. And then my last point needs to move up 1 unit, so I'm right here. And notice this is still going to give you the same exact sine curve. The whole thing has just been moved up 1 unit. So this next graph that we have is going to be a different transformation yet again. This is something called a phase shift, or a horizontal not horizontal transformation, I'm sorry. It's a period change. And the period is how long it takes, how much of the x-axis it takes to make one full sine curve happen. In our parent function, that's from here all the way to 2 pi. That is what we are going to refer all of our phase shifts with. Since our parent function has a period of 2 pi, if it's being changed, that 2 pi is either going to stretch or it will shrink. And we have a formula that helps us determine whether that happens or not, or how that happens. And the formula is this. It says that to get the new period, you take 2 pi, because that's what our parent function is, and you divide it by b. Well, what's b? So I'm going to rewrite this blue function so that you can easily see it. I'm going to rewrite that x over 2 so that it is 1/2 x. Okay? B, the b that they're talking about is going to be the coefficient of x, not the coefficient of sine. It's the coefficient of x. So that means b is equal to 1/2. So let's plug it into this formula and see how it's going to actually affect my graph. So I'm going to do period equals 2 pi over 1/2. And whenever you're dividing by a fraction, you multiply by the reciprocal. So I'm going to do period equals 2 pi times the reciprocal of 1/2, which is 2 over 1, which is going to give me altogether 4 pi. So instead of it taking just 2 pi units to get through an entire sine curve, it's now going to take me twice as much to get the entire sine curve in there. So that's the idea behind this. I'm going to have to rescale my graph so that it fits this. However, so you can see everything at once, I'm going to erase everything I just drew and extend my horizontal axis. So here we go. Just so that you have the reference, I did rewrite our period up here in the top right. So also keep in mind that we still need to have the halfway mark and the quarter marks in here so that we can still have our 5 key points. We don't necessarily need to know the exact values of those. We will just use them to help us replot our points. Now, period does not affect amplitude. It's not going to affect my maximum or my minimum. What it will do, however, is it's going to be a multiplier of these 3 points, the ones that are going to stretch this way. Okay, so think of stretch as horizontal axis. It will not affect the vertical axis on its own. So, what's nice about this is our starting point is still going to be at the origin. If I do 0 multiplied by any kind of period change, it's still going to be 0, so keep it there. So the first thing that we have to do is extend our ending point. It's not going to be at 2 pi anymore. It's going to be at 4 pi. So that's the first thing that needs to change, is where it ends. So already I can see that this graph is going to be much wider. Now what's the next easiest part is to get the halfway marker. Halfway between 0 and 4 pi would be half of 4 pi, which is 2 pi right here. So that is now where that middle point is going to happen. Now we need to get our quarters in there. In other words, we find our halfway point and our our starting point, and split that in half. Well, that looks like it's going to happen at pi. Okay. Now originally that quarter way mark was at pi over 2. That was where our peak was. So instead of my peak being at pi over 2, it's now going to be at pi. So I'm just going to move that over here. And just based on the pattern that I see, my new minimum is not going to be at 3 pi over 2 anymore. It looks like it's going to be at this point here, whatever that may be, because it's halfway between this new place and this ending point. So now that I have all my 5 key points in here, I'm going to just clean this up real quick. I'm just going to connect them, and I should have a graph that is the same exact thing as my parent function, just stretched out so that it takes twice as long to end. Like that. So that's going to be the effect of a period on the parent function. Our last transformation that we're going to take a look at is the horizontal shift. So this is where you have a value being added or subtracted to your x, to your theta, inside grouping symbols. You've got to have the parentheses here to know that it's a horizontal shift. And I abbreviate that as horizontal shift, HS. And what's interesting about horizontal shifts in any function, not just trig, any function, is that it always moves in the opposite direction of the sign. So if you have a function, if you have this x that's subtracting a value, it's actually telling you to go to the right. If you have a value that's being added, you're actually going to the left. Oh, not leg. And that's going to affect all of your points. Okay, so all 5 key points are going to move. So we may have to extend our horizontal axis to accommodate this. So I'm going to just erase the ends here and here and extend them a little bit and see if that's enough. Pi over 2, remember, it's only 90 degrees. It's right here. So I'm only going to be moving this 1 unit this way or this way. So I don't need to extend this that much. But I am going to do this enough so that there's an extra tick mark on either end. So over here and over here. Again, it's not necessarily super important to know exactly where those are unless the question is asking for that. But when graphing it, you just need to have those tick marks present. So pi over 2 is 1 unit here. So all of my 5 key points are going to move, in this case, to the right because this is a negative. They're all going to move to the right by pi over 2 units. 1 complete unit from start to end. So I'm going to pick up my first point, which is at 0, 0, and he's going to now move to pi over 2. That's going to be my starting place now. My peak, my maximum up here, is going to move a complete unit of pi over 2 this way as well. So it's now happening at pi, and so on and so forth. I'm going to grab this one, move him over, and then I'm going to grab my minimum, move him over, and then my ending point is also going to move. So when you are done with all of your graphing, it should be the exact same curve that you started with, but moved slightly to the right. And I don't know how I did this, but somehow this looks three-dimensional, kind of looks like a slide, which is cool. I'm going to show you just a couple more examples of a couple of these transformations done at a single time. That's where this gets a little bit trickier, when you have to take into consideration more than one transformation. So here's our first multi-transformed function. And before you start plotting anything on your graph, make sure that you know which transformations are actually happening. So we have a coefficient for sine that's going to affect the amplitude. In other words, the peaks, and only the peaks. We also have this -1 out here, and we have to determine if it is a horizontal shift or a vertical shift. Now, because there are no parentheses around it like that, it's going to be a vertical shift, and vertical shifts affect all 5 key points. So how do we plan this? Here's my recommendation. Do one transformation at a time. So to accommodate this, I would suggest putting in a few more marks on your grid just to make sure you have a decent plan. Now, this could all go kaput and you might be in some trouble, but it's a good place to start. Start at positive 2 pi, get your quarters and halfway marks in there, and do the same thing at the other end too. This would be negative 2 pi. Halfway mark and your quarters. Also, if it helps, sketch your parent function. I would do this lightly in pencil with maybe dashed lines so that you can easily, very easily move it. Again, our parent function is here, 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 and here with those 5 key points. Just going to lightly outline that so we have a reference. There we go. All right, let's work with the amplitude first. So when I work with the amplitude, and I'm going to do this in 2 different, no, never mind, sorry. I'm going to do this in 1 color. I'm going to start with the blue. Remember that it's just the amplitude. So I'm going to take all my amplitudes, my maximum and minimum points, which are here and here, and I'm just going to halve them. So instead of at 1, we're going to be at a half. instead of -1 will be at -1/2. My other points, since they are neither maximum nor minimums, are going to stay the same. So this is my first transformation. Okay? So now what we're going to do is we are going to take all of this and we're going to take care of the vertical shift now. So I'm going to take all of my 5 key points and they are going to all move down a whole unit. So my beginning point at 0, 0 is going to go to -1 down here. My maximum, which is at +1/2, is now going to be at -1/2. My halfway point is still going to be at -1 if it moves down 1. My -1/2 becomes -1.5. I'm going to erase that here. And then my ending point moves down a whole unit. So here. So your final graph will be this. Now, if you were to turn this into me and your graphs look like this, I am not going to know which function is your final. So please go back and erase the other parts that you used to assist you. Okay? That shows me a clear picture of what the final answer is. We're going to do one more and then we're going to be finished. So here's our final graph. And again, we need to decide first what kind of transformations we have. It looks like I have a coefficient of my x, or my theta, which means that this is going to affect the period. This is where we're going to have to use that little formula of p equals 2 pi over b. And b is the coefficient of x. And here we have an added or subtracted value inside parentheses. This is a horizontal shift. And in this case, since we're adding one, we are going to be moving to the left. Remember that horizontal shifts are always in the opposite direction. So mainly what's happening here is my entire horizontal axis is either going to be shrinked or stretched, and I'm going to be moving left to right. I'm sorry, right to left. So we really need to accommodate a lot of changes. Before we do anything with making our marks like this, we need to figure out what the period is so that we can plan it out really well. So we're going to do p equals, and we've got 2 pi over, in this case, a fourth, which means that when I multiply by the reciprocal of a fourth, we get 2 pi times 4 over 1, which is going to give us, holy cow, 8 pi. So what we're going to do is we're going to make our ending point out here 8 pi. Don't go all the way to the end, because remember, we still have a horizontal shift to accommodate. We're going to get our halfway mark and our quarter mark, and then we're going to repeat that on the other side. So about -8 pi here, halfway, quarters, and then we want to get maybe another couple tick marks on the outside, just again to accommodate that horizontal shift that we may or may not really need the extra space for, but this is going to make sure that we're okay. Since there's no vertical transformation of any kind, there's not an amplitude change, there's not a vertical shift, that means we're still going to be at +1 and -1. So here we've got a pretty good plan. Again, if it helps, draw your original parent function. This is going to be really tricky, and here's why. If this is 8 pi, this is 4 pi, which means this is 2 pi, which means my entire parent function needs to fit between the origin and 2 pi. So it's going to look something like this. This is not going to look pretty. Something like that. Okay? Again, we have our 5 key points at the origin, at the maximum, at the center, at the minimum, and at the ending. So we're going to take care of one transformation at a time. We're going to start with the period shift. So basically, we need to move everything but our starting point all the way out to the end. So keep the starting point at the origin, grab your ending point, and move him to 8 pi. That was this point right here. Next, let's get our halfway point, which is this right here. Now, half of 0 to 8 pi would be at 4 pi, so that's going to move here. Now we can easily see where our quarter points are going to be. It's going to be at 2 pi and at, that's not 3, what am I doing? That's 6 pi. Okay, so 2 pi is where my maximum is going to happen, right up here. 6 pi is where my minimum will happen, which is down here. So I'm going to erase what I don't need anymore, and I'm going to clean this up, and I'm going to sketch out the period shift. So something like that. So I have my period shift taken care of. Now I have to take care of the horizontal translation. So I now need to take every single one of my 5 key points and move all of them to the left by 1 unit. And I should have written that differently. Forgive me, we're going to change that 1 to a pi. I was thinking of 1 unit, which doesn't make any sense when you're talking about pi. All these numbers, if you were to multiply them out, would be decimals. So we don't want a whole number. It's going to make this really messy. So my apologies. We're going to just change that to pi. It's still being added, which means we're still moving to the left. We have to decide how much of each of these tick marks represents a single pi. Now, since there's a lot of mess on the right-hand part of my graph, I'm going to use the left-hand part to assist me in just figuring out how much this is going to move. If this is 8 pi, negative 8 pi here, I'm going to split this up into pi units. So 8 equal pieces. So 1, 2, 3, 4, 5, 6, 7, 8. So if I were to move everything by pi units, that's a single eighth of the way tick mark. This would be negative pi. This is negative 2 pi, negative 3 pi, and so on and so forth. So I have to move all of my points to the left by an eighth of my period. So to do that, we can do exactly as we just did. So whatever your total distance is for your period, split it up into pi units. In other words, if I just divide this by pi, I just get 8. So I need 8 equal pieces, which I already did up here on the axis. So I'm going to take all my green points that I have here, and I am going to move them. Get my green, there we go. To the left 1 unit. So here, this one moves to here at 1 pi. This one moves to 3 pi. 6 pi moves to 5 pi. And 8 pi moves to 7 pi. So subtract all of them by a pi. And then there we go. This is our completely transformed function. Again, if your graph looks like this, erase everything that is not your final answer. So the reason why this is a sine and cosine tutorial, all I've been working with are sines so far, but cosine works the same exact way. So just to wrap up, if we were to take a look at our cosine function instead, we would have, instead of the 5 key points for sine, we would have these ones instead. So we're going to do 0 pi over 2 pi, 3 pi, 3 pi over 2, and 2 pi. So these would be our values instead. When we graph that for our parent function, we do this the exact same way. We get our maximum and minimum. We have our 5 key points ready to go. 0, 1 is up here. Pi over 2, 0 is here. Pi negative 1 is here. 3 pi over 2, 0 is here. And 2 pi, 1. So this actually looks like a U instead, but all the transformations affect this graph the same way as they affect sine. So if we put this all together, here's our summary, and A, B, C, and D represent all the different transformations that we've already seen. So just to summarize, if you have a coefficient of your trig function, that is amplitude. If you have a coefficient of your x, that is a period change, where you need the formula of 2 pi over b. That's where that b comes from, by the way. If you have an added or subtracted value inside the parentheses, that is a horizontal shift. And if you have a value that's being added out at the end, that is a vertical shift. Please keep in mind that this d could be written in the very front. It could be d plus all of this. Okay, so that vertical shift could be at the very end or in the very beginning. So just watch out for that. And that's it. That will complete this tutorial.